Hello, my name is Elaine Tintoni, and I'm the lead online math instructor at Itawamba Community College. Welcome to this video series in which we'll be going through our college algebra curriculum together using the textbook College Algebra by Margaret Lyle, published by Pearson Publishing. In this video, we'll be looking at section 1.1, which covers linear equations. We'll talk about some basic terminology and we'll solve several equations together. We'll talk about identities, conditional equations, and contradictions, and we will also solve for a specified variable or work with what's called literal equations. I hope that you've printed out your notes for Module 1 from Canvas and that you're ready to write and think with me as we go through these examples together. It really will make a difference if you're writing and thinking at the same time that you're listening. Listening by itself doesn't do you nearly as much good as writing and thinking combined with listening. So if you haven't done that, stop right now, go to Canvas and print the notes, and then when you come back, we'll get started. Okay, before we start solving problems, we need to get a few definitions down. An equation is a statement that two expressions are equal. So an equation is always going to contain an equal sign. Now, a lot of people use the equal mark as something that means in their mind next step, and they use it to chain steps together, but that's not really what the equal mark is for. The equal mark means whatever is on the left is the same value as whatever is on the right. So an equation always contains an equal mark. And a solution is any number that makes the equation true. In other words, any number that makes the expression on the left the same as the expression on the right. Now, to solve an equation means to find all values that make the equation true. We do this by isolating the variable, and depending on the type of equation we have, there could be all kinds of different methods required, and a fair part of the course is going to be learning how to handle each different type of equation. Now, always remember, when we're working with equations, we can do anything we want to one side of an equation as long as we do it to both sides. So if you want to eliminate a coefficient by dividing by it, then you can, as long as you divide both sides by the same number. Always think of an equation like a set of scales. You have to keep balanced. Whatever you do to the left side of the scales, you have to do to the right side if you want to keep the scales balanced. Now, in this section, we are only looking at linear equations in one variable. So a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are some number. X, of course, is our variable. Now, a cannot be 0 because if a were 0, we would lose our x term and we wouldn't have a linear equation anymore. But b can be 0 because if b is 0, it just means we don't have a constant. That's okay, but we can't lose our x term or we won't have a linear equation. So ax plus b equals 0, where the a is not 0, but the b could possibly be 0. Now, a linear equation is also called a first-degree equation, since the greatest degree of the variable is 1. In other words, we will never see x squared or x cubed in a linear equation. We only can have x to the first power. So here are some examples of linear equations. 3x plus square root of 2 equals 0. You see the power of x is just the first power. How about 0.5 times x plus 3 equals 2x minus 6? So this is also a linear equation because we just have x to the first power. How about 3/4 x equals 12? Again, yes, this is a linear equation because we have x to the first power and we have a constant. We don't have x to the second power. We don't have x in the denominator. Notice in all of these, we could get them all into the form ax plus b equals 0. Here I would have to distribute the 0.5 and do a little bit of combining of terms, but we could get it into that form. And the same thing here, we could get this into that ax plus b equals 0 form. Now here are some equations that are not linear. Square root of x plus 2 equals 5. You see we don't have the x to the first power here. We have a x under the radical, and so that's not going to be linear. How about 1 over x equals negative 8? Again, not linear because here x is in the denominator. And how about x squared plus 3x plus 2 equals 0? Again, not linear because we don't have just x to the first power, we have an x squared. Okay, here is the first example we'll look at together. And before we start solving, let's verify that it's a linear equation. So I see x to the first power here, and also x to the first power here. So yes, we are working with a linear equation. Let's start off by distributing our coefficients. Here I'll distribute the 3. That will give us 6x minus 12. 3 times 2x is 6x. And 3 times minus 4 is minus 12, and then equals 7, and here we will have to distribute the minus, so minus x and minus 5. Okay, that's the first step. Now let's combine our like terms. On the left I don't have any like terms, but on the right I do have two constants. The 7 and the minus 5 together make 2. And now we have variable terms on both sides and constant terms on both sides. Whenever that happens, probably the best thing to do is find the smaller x term and eliminate that term. So I'm going to be eliminating the minus x by putting plus x on both sides, and then we'll combine again. 6x plus 1x is going to be 7x, so my left side says 7x minus 12. And on the right side I just have 2. And now I want to eliminate the minus 12, so we'll be adding 12 to both sides. That's going to give us 7x equals 14. And now, still trying to isolate the x, I'll now need to divide both sides by 7, and that's going to give me x equals 2. So 2 is the solution to our equation. Now we could check our work and make sure that 2 is the correct answer, so let me show you how to check. To check, we'll just put the 2 in place of the x, and remember that if 2 is the solution, it's going to make both sides of the equation have the same value. So I'll write the original equation, but wherever I have x, I'll replace that with a 2. And so you see this is just the original equation, but I've replaced the x with a 2. And now we'll use order of operations to simplify both sides. On the left side, 2 times 2 is going to be 4. And 4 minus 4 is 0. And 3 times 0 is 0. So with the 2 in place, the left side equals 0. And therefore, the right side must also equal 0 if 2 is the correct solution. So on the right side, parentheses first, 2 plus 5 is 7, and of course 7 minus 7 is 0, and since we have a match, that verifies for us that 2 is the correct solution. Now, it's not absolutely necessary to check your work on every single equation, but I do want you to know how to do it in case you ever need to. If you have a calculator in your hand, it's an even faster process, or you don't have to write it the way I did here. You can just do it mentally. We could put the 2 here. We could say 2 times 2 is 4, 4 minus 4 is 0, 0 times 3 is 0, and that would save time just not having to write it down. So if you're one of our ICC students and you're taking this online and you're going to be having to type your work into a show work window in My Math Lab, the solving process is what you need to show. The checking process is not necessary here because we checked this answer for our own benefit and not as part of the solving process. In other words, there was no danger of 2 being an invalid solution. It just might be wrong due to a careless error. So the checking is kind of on us, so to speak. Okay, here is another similar example. I hope that you will pause the video and try this on your own, and then after you get it worked, then play the video and just make sure that you did it correctly. So I'll go through this one a little more quickly. So first we'll distribute the 6 and the negative. And now we will combine like terms on the right. And now I have both kinds of terms on both sides of the equal mark. So let's find the smaller x term, which is the minus 10x. And let's eliminate that. So we'll add 10x to both sides. Combine like terms again. And then we'll add 6 to both sides. And that will give us 28x equals 28. Now divide both sides by 28 to isolate the x. And we find that x equals 1. And we could just really quickly check our work, putting the 1 in place of the x. And so I'm going to get on the left side, 3 times 1 is 3, and 3 minus 1 is 2. And so the left side equals 12 when I put the 1 in there. And on the right side, 10 times 1 is 10, and 10 minus 14 is negative 4, and 8 minus negative 4 is 12. And so they do match, so I've verified that 1 was the correct solution. Now here's an example for us with decimals. So you might want a calculator just to make your work a little easier. I know when we work with decimals we find it a little harder to do everything mentally, and so it might be handy for you to have a calculator. So let's distribute our 0.04. That'll give us 0.04x minus 0.48 plus 0.06x equals 1.52. Now we have like terms on the left, so we'll combine our like terms. 0.04x plus 0.06x is going to be 0.1x. And now let's add 0.48 to both sides. And that's going to give us 0.1 equals 2.00. Of course, the zeros don't mean anything. It's just the way it came out when we added with 2 decimal places. I just kept the decimal places there. And let's divide both sides by 0.10. And that's going to give us x equals 20. And just to check, we could put the 20 back in place of the x. Okay, 20 minus 12 is going to be 8. And 0.06 times 20 is going to be 1.2. Now 0.04 times 8 is 0.32, plus 1.2 gives us 1.52, which is a match for the right side, so we verified that 20 is the correct answer. Okay, now here is our first example with denominators. And at first you might feel like, oh, I'm fixing to have to do a lot of work with common denominators. It's going to be really tedious. But the trick here is not to just knuckle down and do the common denominator work. The trick is to work smarter, not harder, by multiplying the equation by something that will eliminate all these denominators. So think about common denominators. What is a number that 3 can go into, that 2 can also go into, that 4 can also go into? And if you're thinking 12, then you are correct. 12 divided by 3 is a whole number. 2 goes into 12 and 4 goes into 12 as well. So what we want to do is multiply both sides of the equation by 12. Now when you multiply both sides of the equation by 12, what's going to happen is you're going to end up having to distribute the 12 through the left side. So I'm going to go ahead and write it that way to begin with. So you see how I've multiplied everything on the left side by 12. Now I'm going to multiply everything on the right side by 12. And now it's like magic. Our denominators are going to cancel out. Here 12 divided by 3 is going to reduce and give us 4. Here 12 divided by 2 is going to reduce and give us 6. Here 12 divided by 4 is going to give us 3. And 12 divided by 3 is going to give us 4. And now let's go through and just solve it like a regular garden variety linear equation. So we will now distribute our 4. And on the right side, we've got 4 times 7, which makes 28. Okay, I see on the left side I have like terms. 8x plus 6x is 14x. Now I see that I have both kinds of terms on both sides of the equal mark. So the smart thing to do is eliminate the smaller x term. So we'll subtract 3x from both sides. That will give us 11x plus 16 on the left side, minus 28 on the right side. Now minus 16, when we want to get rid of the plus 16, that's going to give us 11x equals negative 44. Divide both sides by 11, and you see that x equals negative 4. Okay? Now, just to show you that these are also pretty easy to check, I'm going to go ahead and get us a new slide. And we're going to check our solution, x equals negative 4. So all we have to do is put the negative 4 in place of the x. Don't be intimidated because it's a fraction. So here, this one's not bad, but this might look a little odd to you. 1/2 times negative 4 just ends up looking like negative 4 over 2. And then the same thing on the right side, 1/4 times negative 4 ends up looking like negative 4 over 4. Okay, over here, 2 times negative 4 is negative 8. And our negative 4 over 2 simplifies to 2. Here, negative 4 over 4 is going to simplify to negative 1. Well, when we get over there in a second. All right, so negative 8 plus 4 is negative 4. And we need a common denominator here. 2 becomes negative 6 over 3. Negative 4 over 3 minus 6 over 3 is negative 10 over 3. Okay, over here on the right side, like I said, 4 over 4 becomes negative 1. And then we need a common denominator, so this becomes negative 3 over 3. And that's going to add up to negative 10 over 3. And so now we have verified that negative 4 was the correct solution. But if you're not comfortable doing these fractions, first of all, I would hope that you would go back and review and get comfortable with the fractions because they're not going away. But you do have access to a scientific calculator, even on your exams. So I recommend getting familiar with the fraction function on your scientific calculator. They all have them. And so this kind of thing here where we're doing negative 4/3 minus 2 is easily done on a scientific calculator. And you ought to get familiar with that and take advantage of it. Okay, here's another example for us. Now this is not an example from the book. This is a practice problem that I pulled out of the homework. It does look a little different, so if you feel comfortable, I recommend that you pause the video and try to solve it on your own. But if it looks a little different and you're not sure, work this one with me and then you can work another one on your own. So instead of distributing the 14 here, the 1 over 14 here, I think what I would like to do is just find the common denominator of 14 and 10. So you want to try to think, what is the number that 14 goes into that 10 can also go into? And I guess what I would do is kind of think through the 10 times table. 10, 20, 30, 40, 50, 60, 70, 14 will go into 75 times. So I think we can say that the common denominator is 70. Another way to come up with that would be to say, well, this is 2 times 7, and this is 2 times 5, so my common denominator needs to be 2 times 7 times 5. Okay, so now let's multiply both sides by 70. And if you were thinking that the common denominator ought to be 140, if you multiply both sides by 140, it wouldn't make your answer wrong. It would just make your numbers bigger, and at the end you'd still come out with the right answer. It's just that problems are easier when the numbers are smaller, so it pays off to use the smallest number you can. So, all right, we've multiplied both sides by 70. And we've got 70 over 14, and we know that's 5. And here we've got 70 over 10, and we know that's 7. Okay, now let's distribute the 5. And let's distribute the 7. And now let's do, well, we see that we've got both kinds of terms on both sides of the equal mark. I have x's and constants on both sides. So I want to eliminate the smaller x term. All right, minus 7x on both sides. That will leave us 8x minus 10 on the left and 70 on the right. Now let's add 10 to both sides. That's going to give us 8x equals 80. And then divide both sides by 8. That's going to give us x equals 10. And we're going to check on the next slide and make sure that we did it right. Okay, here we go. About to check our 10 solution. So put the 10 in place of the x, both sides. And we'll just simplify one side at a time. 3 times 10 is 30. And 30 minus 2 is 28. So here I have 1/14 times 28, which is going to be 28 over 14, which is 2. And on the right side, 10 plus 10 is 20. And 20 divided by 10 is 2. And now these two sides match, so we now are sure that 10 is the right solution. Okay, now let's talk about identities, conditional equations, and contradictions. An identity is an equation that's true for every value of the variable. When you have an identity, both sides can be made to look exactly the same. If you're ever solving an equation and the x term disappears and what's left is a true statement like 0 equals 0, then what you have there is an identity. Or it might not be 0 equals 0, it might be 2 equals 2, or 15 equals 15. But if you come up with something where there's no x, but both sides are the same number, that's a true but not helpful statement. So that's an identity. And whenever you have an identity, every number will check correctly. And so the solution set is all real numbers. Now, a conditional equation is what we've been solving up to now. Conditional equations are true for some numbers, not for others. It's a typical equation like the ones we've been doing. They have a finite number of solutions. In our case so far, each equation has had one solution, and you have to solve to find the solution set. Okay, now let's talk about contradictions. A contradiction is not true for any value of the variable. When you're solving a contradiction, the variable term disappears, but this time it leaves a nonsense statement like 3 equals negative 8, or something else not true. It might say 10 equals 20, not true. So in this case, there is no value of x that can make both sides the same. And so the solution set is, we use the empty set symbol, which is looks like a circle with a line through it. In other words, there is no solution. And so on these next few examples, let's try to determine which type of equation we're working with, and then we will determine the solution. Okay, here we go. You can't tell at first what type of equation you've got. You have to start solving it and see what happens. So on this one, it just looks like an ordinary equation. Let's distribute the negative 2. And combine like terms. So on the left side I have negative 2x plus 3x. That's 1x. And now look, both sides are exactly the same. I have x minus 8 on the left and x minus 8 on the right. Since they are the same, every number is going to check. And since every number checks, this is an identity. And the solution is all real numbers. And now let's look at this one. If we start solving, we would probably add 4 to both sides. That would give us 5x equals 15. Divide both sides by 5. That tells us x equals 3. And so this is a conditional equation. It's only true when x equals 3. It's only true under the condition that x equals 3. So this is conditional. The solution is 3. Okay, here is another one. So we would just have to start solving by distributing the 3. And now look closely at this. You can see that something's wrong if you think about it, because both sides have 9x. how can 9x minus 3 be the same as 9x plus 7? You can't have a number and subtract 3 and have that be the same as that number plus 7. It defies common sense. So if you attempted to keep solving by subtracting 9x from both sides, what would happen is your x terms would disappear. And you'd get something silly like negative 3 equals 7. Well, that's just not true, and there's no value of x that can make it true. So what we have here is a contradiction. And in this case, there is no solution. So we could say the solution is the empty set. Okay, now we're going to talk about solving for a specified variable, or we're going to be looking at literal equations, which you probably would call a formula if you saw one written down. A formula is really just an equation with more than one variable. They can be manipulated and solved for different variables. They usually come solved for one variable, but you might want to solve for a different variable depending on how you want to use the formula. We can use algebra to solve a formula for a different variable. And that's what we're going to be doing in this example. So here we have the old interest formula, I equals PRT. So this is just basic interest. P stands for principal, R stands for rate, T stands for time, but you really don't have to know anything about the formula in order to solve it for the specified variable. Here, if we want to isolate the T, what we need to do is divide away the P and the R. So let's divide both sides by PR, and that will cancel the P and the R from the right side, and that will leave us with T equals I over PR. And so we have the same formula, but it's now oriented a different way so that we can calculate T instead of calculating I. And let's do the same thing over here. Now this one says solve for P. Now notice there are two P terms. I don't want this to throw you off. Whenever you're solving for a variable, but there are two terms that contain that variable, the trick to it is always that you have to factor out that variable. You need to get all of the terms that contain that variable on one side of the equal mark together and then factor it out as a GCF. So let's move this P term over to the right. Like that. So I added P to both sides, and now this P term shows up on the right side with a positive sign now instead of minus because I added it to both sides. And now I'm going to factor out P as a GCF. So you see how when I say factor out, it's, it feels like we undistributed. That would be the kind of informal word to use. We undistributed the P, and now to isolate the P, I can just divide both sides by that parenthesis. Divide both sides by 1 plus RT, and the 1 plus RT will cancel from the right side and leave us with P equals A over 1 plus RT. Okay, here's an interesting one, and this one doesn't look like any formula that we've ever seen, but it does have some different variables in it, so it can be solved for any one of these, and they are requesting for us to solve it for x. So the thing to do is going to be to get all of our x terms together on one side of the equal mark, and we can only do that by distributing this 3. So 3 times 2x is 6x, and 3 times minus 5a is minus 15a, and we've got plus 4b. Okay, now nothing over here on the left can be combined. So now we're ready to collect our x terms on one side and our any other kind of terms on the other side. So what I've done here is I've brought the x, the 4x, to the left side. So of course when you move it across the equal mark it becomes negative. And we'll do the same thing with these two. We'll move them to the right side. And of course when we take them to the right side they change sign. So now we've got 15a minus 4b and the minus 2 still over there. And so now the 6x and the 4x will combine and give us 2x. And now to isolate the x, all I really have to do is divide both sides by 2. And that's done. Okay, we've got one last example for this section. This one says solve for h. S equals 2LW plus 2WH plus 2HL. This happens to be the formula for the surface area of, say, a box. This would tell you, for example, how much wrapping paper it would take to cover the outside of a box. 2LW, where L is the length and W is the width and H is the height. Okay, now since they're asking us to solve for H, we notice that two of our terms contain H, so the key is going to be to get these two terms by themselves and then factor out the H. So let's move this term to the left side, which is going to give us S minus 2LW on the left and 2WH plus 2HL on the right. Now we want to factor out the H. And if we factor out the H, or in other words, undistribute the H, that's going to leave 2W plus 2L in the parentheses. And now we just want to isolate the H by dividing both sides by that parentheses. And that's going to do it. And, you know, there's nothing over here that you can cancel. I think some people might be tempted to try to cancel the 2's or the L's here. But remember, you cannot cancel from terms. So the 2L is part of a term. And this 2L down here is also a term. And terms never cancel. You can only cancel factors, which is why we were able to cancel out this whole parentheses a while ago, because this is a factor. We factored out the H. So I hope this will be useful to you. I know that when I was in, say, chemistry and physics, I used to use this kind of thing all the time, and still do. Anytime you have a formula that's solved for a variable other than the one you want it solved for, then this is the thing to do. So, practice some. Get in my math lab, practice. Send your instructor questions if you get stuck on anything and the online help just isn't getting the job done for you. Then don't wait. Don't hesitate. Go ahead and send your questions into your instructor or go to the tutoring center and get some help. But the very best thing you can do for yourself all throughout the course is to work on your homework a little bit every day and get help early. Don't wait till Sunday evening to start working on your assignment that's due Sunday night, but work on it a little bit every day and get help early when you need it. So good luck, and I'm looking forward to working with you.